Let's assume that you have a data set with variables such as the individual's age, height, educational background, and so on. Before you choose your statistical method of analysis, you must determine the type of data that you have for each variable. Think of data types as a way of categorizing different types of variables. There are 4 types of data, or scales: nominal, ordinal, interval, and ratio. Nominal data are just identifiers. For example, the digit 1 for left-handed people and 2 for right-handed. These numbers have no mathematical meaning. Ordinal data tell us about the order of things. For example, the results from a tournament tell us what teams came first, second, third, and so on. Interval data are just like ordinal data, but the distance between the intervals on the scale is always the same. Ratio data has all the features of interval data plus a meaningful 0 point. In nominal data, numbers are just identifiers with no real meaning. These data have no order, and if you change the order of the categories, the meanings will not change. A number identifies an individual, a color, or a country, and that's all. Another example is the number on the back of the team players that are used to identify different players. Players with the digit 2 are not half as good as players with the digit 4. Sometimes nominal data are also called categorical data. The word nominal comes from Old Latin and it means name. In summary, the numbers in nominal data or on a nominal scale are just names. Ordinal data are the same as nominal data, except that you can put things in order. A lower value indicates something different compared to a higher value. For example, a lower value means less of something compared to a higher number. However, the data doesn't provide any information about the exact interval between the numbers. For example, the difference between scale steps 2 and 3 is not necessarily the same as the difference between scale steps 4 and 5. Examples of ordinal data are numbers on a scale 1 to 4 that indicates people's educational backgrounds. A higher number means more of a particular property. However, the interval or the distance between the numbers doesn't make any sense. For example, the digits 1 and 4 regarding people's educational backgrounds doesn't provide any information about the interval or the distance between elementary and grade school. All we know is that there's some sort of rank order. In summary, the numbers in ordinal data or on a ordinal scale are used for naming and ordering. Now, the 2 last types of data are interval and ratio. But first, we need to pause and discuss the concept of 0, the number we all know. It's quite a unique number. So, before we proceed, I want you to understand that in science, in general, the concept of 0 has many meanings depending on the context. Let me give you 2 concrete examples. In the first example, you measure height or weight, or you count the total number of schools on a long street or the number of left-handed teachers working at those schools. In this example, 0 is the starting point from which to measure or count. Now, in the second example, on the other hand, you use the digit 0 to mark the initial condition of something. Let's assume that you're sitting on a beach looking out at the ocean on a windy day and you want to measure the heights of the waves. Here you use the digit 0 to mark the normal sea level, the initial condition. I want you to think about these 2 examples. In the first example, 0 indicates that you don't have anything of whatever you want to capture by those numbers. It is a true 0. In the second example, the digit 0 is just an arbitrary starting point. Although 0 is used to indicate something, it still means that you have some of whatever you want to capture by those numbers. The waves are still there, even though they are at level 0. So 0 just means that they are in balance. So my message is, in summary, the digit 0 can be all of those things depending on the context. It has a life of its own and it can be used in various ways. Moving on, interval data have distances with the same interpretation throughout. The differences between numbers are always equal and meaningful. The interval level, however, lacks a real non-arbitrary 0. There might be an arbitrary value of 0. For example, we might use a scale with a value labeled not at all or 0, but the properties being measured are always there. They're not gone. Finally, ratio data are like interval data, but there's also an absolute 0 point where the properties are gone. For example, height or weight. Because those variables do have a true 0, i.e. the complete absence of a property. This makes it possible to discuss ratios such as twice as much as or half as much as, hence the name ratio data. 4 inches is twice as long as 2 inches. Remember, before you decide what statistical method to use, you must take a look at and categorize your variables. And in doing so, you must use the concept of data types. This concept has a lot of synonyms. Data types are sometimes called types of data. Sometimes it's referred to as data scales. I also see that sometimes it's referred to as levels of measurement or scale of measure. However, they all mean the same thing. In social science, the most used classification was developed in the 1940s by psychologist Stanley Smith Stevens. Nominal, ordinal, interval, ratio. Think noir, which is a French word for black. Exercise. A school teacher asked the students about their leisure activities and provided 4 alternatives. 1. Reading. 2. Gaming. 3. Being with friends. And 4. Other. My question to you is, what data type is this? It is nominal, or sometimes it's referred to as categorical data. A scientist performs a systematic literature review of 100 articles. The results from this review show that 25 articles present nominal data, 35% ordinal data, 15% interval data, and 25% ratio data. What type of data are they? For me, it's reasonable to argue that this is ordinal data, if we assume that there is an order between the categories. The category ratio data is more sophisticated than interval data. Interval data is above ordinal data, and so on. A friend of yours has taken a standardized scholastic aptitude test for his or her college admission. Scores on the test range from 400 to 1600, and the friend got a total test score of 998. What is the data type? It's an example of interval data because we have an equal distance between the intervals on the scale, but at the same time there's no absolute 0 in the scale between 400 and 1600. You watched a YouTube video to the end, and afterwards you noticed that it was only 45 seconds long. 45 seconds. That data, what is its type? It is ratio data because it has an absolute 0. We can easily calculate ratios such as 1/4 of the time or half the time because time elapsed starts at 0 seconds. Okay, it's time to end this video. The type of data determines the statistical tests that you can use. With nominal data, you can count frequencies, calculate the mode of the frequently occurring value, and perform non-parametric tests. With the ordinal data, you can sort the numbers in rank order, count the frequencies, calculate the median and percentiles, and perform non-parametric tests. With the interval data, you can calculate the mean, median, and standard deviations, and perform correlations and regressions. And you can also perform hypothesis tests. With the ratio data, you can perform all arithmetic operations, include ratios, and all forms of statistical tests. In conclusion, you need to think about and analyze the type of data that are in each of your variables that you want to use in your statistical analysis before you start performing those statistical tests. What I'm trying to say and what I've tried to show in this video is that you need to know what data type you're dealing with before you apply your methods, make assumptions, and present your results. If you enjoyed my video, please subscribe to my channel or click that like button. All the best.